Alright class, in this lesson we're going to take a look at factoring completely. And whenever we factor completely, we want to work through basically these 4 steps that I have listed here of what to look for and how to factor. We always have to look for a GCF first. After we look for a GCF, we look for actually these numbers tell you how many terms you're looking at. If you're looking at 2 terms, you want to look for difference of squares or sum and difference of cubes. If you're looking at 3 terms, you can look for magic x or perfect square trinomial. If there are 4 terms sitting on your screen, you're looking at, or sitting at the problem, you're looking for grouping. Okay, so we've learned each of those factoring methods, but each one of these steps tells you how many terms you're looking at in order to use which factoring method. So let's take a look at these problems. Most of these next problems are all difference of squares or sum and difference of cubes problems because there are 2 terms. Notice there's 1 plus sign and then 2 terms. The second problem has 2 terms and 1 minus sign, which means these are binomials. There's 2 things. So that means I get to either look for difference of squares or sum and difference of cubes after I look for GCF. So you always look for GCF first. So on this first problem, the 8mp squared and then 4mp, I look for, do they have a GCF before I look for anything else? So they do have a GCF. 4 goes into 8 and 4, so I get to pull out a 4. They also both have m's and p's. Now remember, I'm looking for the lowest exponent. They both have 1 is the lowest exponent for m and p. So I'm going to pull a 4mp out from both, and if I divide out a 4mp from the 8, I get 2mp because I pulled out 1m and 1p. Now the second one, I divide it by itself, so what's left over is a plus 1. Now this is actually as far as I get to go with this particular problem because I have to look in the parentheses to see if there's anything else I can factor, and there is not. There's no difference of squares and there's no sum and difference of cubes. So that's as far as I go. So, but I will be looking for further steps on each one of these problems. Now in the second problem, you can see that they also have a GCF of a plus b. So I'm going to factor out an a plus b, and then I'm going to see what I have left over. Left over is a 5x minus y. And now I get a little excited because I see the minus sign, so I'm thinking, oh, I have difference of squares. But because there is not a square, either one of them, they're not difference of squares. It's just a GCF problem. So that's as far as this problem goes also, but I have to keep looking for more. I can't just stop at greatest common factor. But it might just be that that's all I have. So now I look at this next problem, and it's still a binomial, so I'm still thinking, alright, difference of squares, because that's what I do when I have 2 terms, but I have to look for factors first, and there aren't any, but this is actually difference of squares, because 8 squared is 64, so this turns into 8m squared, and this is 9n squared, so that's 3n squared, and because there's a minus sign in the middle, I get to use the difference of squares formula, which is, if you recall, you write the 2 numbers in parentheses, 8m and 3n, 8m, 3n, and then the first parentheses you put a plus sign, second parentheses you put a minus sign, and you've got your answer done. Now, you look for more factors if possible, so we don't always stop at the first level of factoring, but there's nothing that these 2 have in common, there's nothing that these 2 have in common, but you have to keep looking for GCF, keep looking for other ways to factor. So now I look at this next one. There's 2 terms. Now, because there's a plus sign and a cube, I want to think about sum of cubes. So I have to think through, is 1000 a cube of something? And the answer is that 10 to the 3rd power is 1000. So 10 times 10 times 10 is 1000. M, so 10 to the 10m to the 3rd. And then, of course, 1 cube root is 1. So this is 1 to the 3rd. So this is sum of cubes. And so I have to think back to my sum of cubes formula, which is a plus b times a squared minus ab, because this is a plus, it's the opposite sign, plus b squared. So the a is my first number, the b is the second number, so I just rewrite this to be 10m plus 1 times 10m squared minus 1 times 10m, which is just 10m, and then plus b squared, which is my 1. 1 squared is 1. So we say plus 1. And then I should, oh, I didn't put parentheses here, sorry. My 10m squared. So I need to simplify this to make it 10m plus 1 times 100 m squared minus 10m plus 1. Okay, so what I should do here, because I have a trinomial and I'm supposed to be factoring completely, which means don't just stop after one factoring, I need to look and make sure that I can or cannot factor that. And the only way to factor that, because there's 3 terms, a trinomial, is to do magic x. So I need to check to see if it is actually factorable. Now in the last lesson we didn't, because it was just factoring one step, difference of cubes, or sum of cubes. But in this case I actually have to check. I'd multiply the 100 times the 1 to get 100 on top and negative 10 on the bottom. So I have to ask myself, is there anything that multiplies to be 100 that adds to be negative 10? And thankfully for us in this case, the answer is no. So because there is nothing that multiplies to be 100 that also adds to be negative 10, there's nothing I get to do, nothing I have to do further. This is my final answer for this problem. It's factored completely. Okay. So now we look at some more problems that are about factoring completely. And we look at this first one, and our first thought, and what I see very often with students, they get confused because they see the square, and so they start doing square roots because we're used to that, and we're thinking, all right, this is 5m and this is 11, so we can do, and they're thinking difference of squares. But the problem is this is not a difference problem. You can see there's a plus sign in the middle, and this isn't sum of cubes. There's no sum of squares formula, so I can't do sum of cubes. I can't do difference of squares. So I have to think back to, all right, well, there's nothing I can do there with difference of squares or sum of cubes, so do they have a GCF? That's basically all I can look for at this step. And because 25 is only divisible by 5, and 121 is only divisible by 11, there's really nothing I can do. That's as far as you can go, so this is not factorable. So even though we've got all our steps of factoring, we can't always do something. So be careful to think through, can you actually do the step that you're trying to do on that particular problem? But then if we look over here at the 25m squared, this one is sum of, it looks like sum of squares. Because again, we're looking at this thinking, all right, 25m squared, so our mind's thinking, all right, this is 5m, and you might even be thinking about what the square root of 625 is, and you're thinking 25. And you're thinking, all right, so I get to do difference of squares. But again, be careful. This is not a difference of squares problem. But it is actually a factoring problem that has a factorable answer. So again, this first one, this was not factorable. The second one is, because it does, again, have a GCF. So you do have to be careful and watch for your GCFs. They both are factorable by 25. 25 goes into 25. It also goes into 625. So I factor out of 25, and then you're left with m squared plus 625 divided by 25 is 25. So there is a step, a single step of factoring I can do with this particular problem, but that's as far as you can go. So again, you're working down that list. The first thing we're supposed to look for is a GCF, and then you work down to see if there's sum of cubes, difference of squares, and that kind of stuff. And this is my final binomial factoring problem. And so let's see what we think on this problem. We have 48 k to the 4th minus 243. Now 48 and 243 do have a common factor, so we have to do GCF with 3. 3 goes into 48, it also goes into 243. Because at the first step, 48 doesn't have a square root. So I can't do difference of squares, even though it looks like a difference of squares problem. 48 can be divided by 3, and that gives me 16. So I pull out a 3, and I get 16 k to the 4th, and then 243 divided by 3 is 81. So now that I've done a GCF, I actually can look back at my problem that's left on the inside and say, alright, well that actually still looks like difference of squares. And it actually is at this step. I got 16k to the 4th, I can square root that, and that would give me 4k squared. 81 square root is 9. So this actually can be further simplified, where this stuff on the inside of the parentheses turns into 4k plus 9 and 4k minus 9. So this is what the inside part factored to be, but you've got to be careful because there's still a 3 that's supposed to be on the outside. So your final answer has to have the 3 in there, and you say 3 times 4k plus 9 times 4k minus 9. So again, looking at the original problem, you have to do a GCF, so this first step was GCF, and then the second step you have to notice on the inside of the leftovers we have difference of squares. Okay, and then once you do your difference of squares, you combine it with that first GCF, and you'll have your correct answer.